Hello, this is P. Chaitanya from NSID College. Today I am presenting my project related to IoT. The project is based home automation project. It is based on IoT. I included IoT in this project. So today we are going to the project introduction. Before that, I want to explain from where I learned these skills and how I did this project and what resources I used. I will explain that. First, I am introducing where I did the internship. This is our internship platform, MXC Information Technology, and it is a 2 month secure program in Bangalore with organized standard learning approach. It is an online internship by LMS support. The students learned how to do the projects using IoT and what are the applications. Free applications are used to do the projects and execution simulation for everything. This is about internship platform. And what is IoT? IoT is combines physical objects with network connectivity. It's the network of devices embedded with electronics, software, sensors, and connectivity that collect and exchange data. And it is about the sharing data to the physical components. Like nowadays, we are all using so many electronic devices, but we don't know how they are operating, how they are executing the instructions we are sending. For example, there are washing machine and electronic oven, fridge, all are there. They are includes IoT. That means if we select one button, that pass some instruction that is executed by the machine. And these are some examples of IoT devices and electronic watch and CC cameras, surveillance cameras in home, and also there are electronic oven. Nowadays there are so fans are building with IoT and also keys, lock keys. So these are the IoT devices examples. And these are the sensors we use to perform hardware applications. And there are so many types of sensors which performs different tasks. Every sensor having their own specific function to do the any operation. Not one sensor can do the everything. Every sensor has its specifications. And for example, alcohol sensor, ultrasonic sensor, IR optical sensor. These many sensors are there. Every sensor performs their own task. For example, alcohol sensor, it detects the alcohol, and the ultrasonic sensor detects the range, and it will pass the distance from how much distance between the object and the sensor. And LDR sensor, which is used to detect the light, and also the sensor is used in this project. So you can see in that, like gas sensor and gyroscope sensor, range sensor, and photodiode, proximity sensor, PIR sensor. There are so many sensors. And how the sensors will work. These are sensors, but they want some instructions to work. By using coding, we will give instructions to the sensors. The coding is basic, intermediate, and advanced level coding is there. But now we are using the C or C++ coding. In this project, we use C language coding. So by that, we are giving instructions to the sensors like how much quantity they has to detect, and how should they work, what is the delay time. They are all in the program. So the program, according to the program, the operations will be done and the output will be collected to the given input. And this is the home automation project requirements. This is a control systems like guardian light control system. By executing single project, we made a complete home automation project. And first we use guardian lights control and then temperature control like heater control. There is threshold temperature management and also water management, water tank control, inlet and outlet valve control, display water volume. These are all done by the Pixim Lab and also Blink IoT app we are using to send the instructions like but we are creating buttons in the Blink IoT app to operate all these things. For guardian lights we are using LED and also the LDR sensor to detect the light and when the light is falls on the LDR sensor that is considered as a daytime and then the garden lights will be off. If there is any no light felt on the LDR sensor, it doesn't detect any light means it considered as a there is no light in outside, then it is considered as a night time. So the garden lights will be on like temperature control, heater control, threshold temperature management, water management. Also, there is a water tank control to control the water tank like inlet valve and outlet valve. How much volume water is there in the water tank and how much we are giving like for certain quantity we are giving for you. If you use some water in that, it has to automatically on the inlet valve to fill the tank like that. And these are the hardware components we used in this project. Like the main component is Arduino Uno. The model of Arduino Uno in Pixim Lab we used is Atmega 328P microcontroller. So with 6 analog inputs and 14 digital pins, USB connector and ICSP header. So LEDs and temperature system, light indicators and temperature sensing components are there in that. And 16:2 CLCD display, liquid crystal display for system status in the display. And we are using display to see the how much quantity water in there in that LCD and the heater and cooler on off status and inlet outlet were off and on status. And earlier sensor I already said that it is used to detect the light how much if light is falling in the sensor or it is empty. And EDS W550 there is a Ethernet shield, it is used to send the data to the Arduino or microcontroller to perform the actions which we send to the Blink IoT app. And PCF857 I2C output expander providing 8-bit bidirectional port for microcontroller interface. And this is PCF8574 used to send data to the liquid crystal display. So by that the display will be operated. And this is the Arduino pair Arduino Atmega 328P we used in this project. So using this Arduino we perform all actions in the project. So this is a crystal display and this is a 16:2 and this is ICPCF874. This is the temperature system. Looks like this. There are heater pin and cooler pin, temperature tag, VCC and ground. By this temperature system, we can collect the how much temperature is there and it is displayed on the this board, CLCD. And this is the LDR sensor. We are in the first thing. LDR sensor. Silent on nama. This is the LDR sensor we are using to perform the LEDs, how much light is falling in the sensor and how to perform the actions. And this is the LED, single LED is used to show how it is working. So we can conclude any LEDs in this place, how much quantity you require. You can add how much that much of LEDs by connecting to that. And this is the Ethernet shield, look like this W5 00. It communicates between the Blink IoT and microcontroller. It shares the instructions uh, from Blink IoT to Arduino. And this is buttons created in a Blink app, given as Arduino, and you can give any other name. I created heater pin and cooler pin, and this is a gauge to show the temperature, and also another side I created inlet valve, outlet valve, and gauge to show the volume of the water. And there are four buttons and two gauges I created, and one for the temperature system and one for the water tank. And this is the project how looks when all are connected by side. And this is the CLCD, this is the CLCD, and this is the LED, and this is LDR temperature system and Ethernet shield. And also we can see this is the tank, water tank, serial remote tank. We taken in the Pixim lab. All of the project execution done in the Pixim lab. By using Pixim lab only, we performed all these tasks. And in CLCD, you can see this is the temperature 27.34 detected by this temperature system. And also this is the 3000. This is the volume of water tank. See here you can see I given volume of water tank. This is all includes in the code which we dumped in this. So by that only it performs. So I give 3000 volume, so it shows 3000 value. And inlet valve off. You can see there is no water falling from inlet because it is full, it is stopped. So then if there is outlet valve on, you can see water coming from here. We will see that in the project execution. This is to see just idea. And all I explained here, whatever there, only these components only we used in our project. And okay, let us go for the project execution. And I am opening Pixim lab. Yeah, here you can see this is the Arduino Uno board. Arduino Uno board at Mega 328P. So in this I already you can upload code from load hex file, and where I saved my file in a desktop from automation build. This is my code. So if I click and I click it open, it will dump in this. So according to that it will operate. And for connection of the water tank, you have to go for the configure, and you can select the two comms, and here we have to select the com 1, and I created another com also 2, com 1 to com 2. So I selected in this, you have to go for tools and go for serial remote tank. Yeah, this is the serial remote tank. In here you have to select com 2, but and after that you have to click on connect. I am not clicking on connect because I already created another serial tank connected to the COM2. Yeah, you can see this is the serial tank I already connected to the COM2. So when we are going to the spare parts, you can see the spare parts, and there are inputs. Here you can see inputs and outputs. Outputs you can see this is the outputs. And ITC, we use LED, LCD, ITC we use in this project, and also in LEDs we taken only one LED from these many LEDs. I am removing this, but it is not required. We already taken LED, and this is the LDR sensor. You can see when I decreasing the intensity of fall sunlight, the light will automatically giving off. And because this is considered as a there is no light, there is light is falling on the LDR sensor. When I am increasing the intensity, you can see the light is on. And the temperature system is controlled by the Blink IoT app, and also the water tank is also controlled by the Blink IoT app. So first I will connect my mobile to this, then You can see every actions performed by me. Wait a minute. See, this is the Blink IoT app. I am sharing only this app, so you can see only this app in this. So this is the Arduino I showed in the PPT. I opening, I will show you from the beginning. When I am going to this, see, I am clicking in this. I am clicking in this, and then I am going to Home Automation. This is the project I created. You can see our buttons I created. So I created all buttons here due to I have to create one another tab here. So but when I am here creating another tab, it's asking to upgrade, so I created only in one tab all buttons. So this is the heater button, cooler button, this is the temperature volume source, and this is the volume of the water tank, and also inlet valve, outlet valve buttons. Yeah, and we will go for the execution part, and this is the buttons. If it shows green button here, it includes that the system is on. Our system is on. So if we open, we can see here there is a CLR off, means cooler is off. We are seeing that there is no fan is rotating here, so it converts as a cooler off. And I am opening this. You can see if I put it this side, and you can see here I am owning the heater on, and it shows here heater is on. And when the heater is on, you can see the temperature is increasing here, 28, 32. Like this, the temperature is increasing. It will goes up to 35, 36 like that, and then it will automatically off, because I given that in the code already. So if it more than 35 degrees, so the heater will be off. Automatically it will off. I will not off the heater. It will automatically off. It is a built-in code. So you can see the temperature is increasing 34.67, 35, and also you can see it is updating in every second here in Blink app. So it is 35.16. The heater is automatically off. So you can see the 30.5 and it is getting down. It will not get fully down, but it stay like a little bit it getting down. And you can see I will on now I will on the cooler button. So you can see it will cooling down up to the original degree Celsius. So now you can see 34 degrees Celsius. It is step by step decreasing temperature at 31. Here you can see it is taking some time because in my mobile it's showing, but it is screen sharing, right? So that's why it is some late. So you can see here 29.03028.81, and this is it will decrease, no problem, because of the screen share it will become like that. Yeah, you can see 28, and when it comes to the original temperature 27.34, it will maintain the constant temperature. So then the cooler will off, and as you can see this is a light intensity already I showed, and the light is falling, it will off, and when the light is not falling the LED will be on. According to the we set here the resistance that will work, we can set in the code. So and we are going to the water tank. In this water tank I already shown you how to connect the water tank. So now I am showing you the operation of the water tank. See, you can see this is the button, inlet valve button, and this is the outlet valve button, and this is the volume of water tank 3000. You can see 3000 mentioned here. So when I am on the inlet valve, you can see water is falling from the top, and it is full, so that will be off automatically because already it has 3000 volume. So if I open outlet valve, you can see the water is going through the outlet valve, and it is decreasing 2500, 2400. Yeah, it will also show in the automatically show in this gas, and when it is going below the 2000, you can see below 2000 the inlet valve will be automatically on. If I off also, it will automatically on because in the code I gave, when it goes below 2000 automatically on the inlet valve to fill the tank. See, you can see if I off, and also automatically it will on in a second. This is the function we included, and when we off the outlet valve, it will start filling the tank, and I will show you one thing. And if it goes 2000 above, I am offing this. So now you can see it will not fill in the tank because only when the volume goes below 2000 then only it will fill the tank. If it is above 2000, it will not automatically fill the tank. After going to below 2000 only it will automatically fill the tank. If I open outlet valve, you can see 2130, 2020. So when it goes 2000 below, automatically it starts filling. Okay, and I am offing the outlet valve. When the tank is full, goes to 3000, it will automatically off because there is no water wastage. See, yeah, see, this is automatically off. And this is the operation using Blink IOT app. We are doing all these operations, creating buttons in Blink IOT app. These are the buttons creating in Blink IOT app. So we are performing all these actions. Now I think so the Blink it will done, and once again I will show this. See the heater and cooler is. When I am on the cooler, you can see the fan is rotating, so that's why it is a sign for that the cooler is on. Yeah, you can see this is cooler is on. When I am offing the cooler, it is cooler is off. You can see when I am on inlet valve is inlet inflow is on, and I am off inflow is off. Outflow, if I have on outflow is on, and also the decrease in the volume of water. If I off, the outflow is automatically off. it will show the what we are performing actions, it will show in the CLC. So this is the operation, and yeah, we are done with Blink IoT, so I am closing this. This is the final outcome of the project, and yeah, we all seen these components, how to perform the actions and how to use. We all seen, and also this is a simulation successfully simulated home automation using Blink IoT and Pixim Lab, where LEDs, temperature system, and serial tank represent real-time lights, heater, cooler, and water tank. And also control interface CLCD acts as dashboard displaying events. Uh, Events means what we're performing actions like cooler off, heater off. What are we performing? That event. Those are called events, and those are displaying in the CLs. And blink button widgets control heater. Yeah, this is only there. Blink button widgets control heater, cooler, inlet and outlet valve, gauge widgets display temperature and water volume. And the key achievement is integrated IoT principles with embedded systems to create a functional, remotely controllable home automation prototype with real-time monitoring. Real-time monitoring means how much volume is there in the tank. We can see time to time in the CLCD, and heater is on or heater is cooler is on or off. We can see in the CLCD. So there is no late if we suddenly forgets to off the tank. After filling it only automatically turn off the motor. And also if we if we forget to on the motor or inlet or water, so it will automatically have certain decrease in the water. So that's how we implemented this project, and I think everything is good, and this done with the project. This is the final outcome of the project. I am P. Chaitanya. Thank you.